Hey students, okay, I'm going to be doing a Norton circuit and I'm going to do the general approach. Right here, this 500 ohm resistor is RL, so you cannot do a source conversion. So we all know that this current is going to be going this way, plus to minus. And so there's only really two unknowns, I1 and I2. The general approach is as such. You put the polarities for each individual box, plus to minus, because we're going this way. This one, we're going plus to minus, plus to minus, plus to minus. As you can see, this one is opposite. So we start here, and basically we're going to write our equations for each of the boxes. So we start here. We have plus 700 I1, because it's 700 and it's I1, plus 1K I1, but it's also minus 1K I2. Keep on going. Minus 23 volts equals 0. We set everything to 0. Then we combine like terms. So we have 700 and 1K for I1. So we have 1.7K I1 minus 1K I2 equals this negative 23 has to go to the other side of the equation, so it becomes a positive 23 volts, and that's our first equation right here. Now we're going to go around this circle. We start here. It's plus 800 I2. This is shorted, so this doesn't count. Plus 300 ohms I2 plus 1K I2. It shares the current, so it's minus 1K I1 equals 0. We put like terms together. We always do I1, I2, I3. So it would be negative 1K I1 plus, we have 800 I2, 300 I2, and 1K I2. So that's 1.8, that's 2.1K. 2.1K I2. There's no voltage there, so it equals 0. And this is our second equation. We put these equations in our calculator, and we get the I1 and I2 current. It would be for this. So let's try that. This is a different calculator than you guys are used to, but I'm going to show you on mine. Simultaneous, there's two unknowns. The first one is 1.7K, negative 1K, 23 volts. We have negative 1K, 2.1K, and 0. We press solve, so our I1 equals 18.79 milliamps. 18.79 milliamps. Our I2 is 8.95 milliamps. Okay, neither one of these were negative, so we picked the right polarities for this. So when we come look at this, we know that this current is flowing this way on this side. Here, we know that this current is flowing like this on this side, so it's a plus to minus. Because they're going in opposite directions, we take 8 milliamps from 8.95 milliamps, which is here. So our I Norton is simply 0.95 milliamps. Then, so here's our load resistor to 500 ohms. Then we have to get our Norton. How do we do that? We open this, we short the battery, and then we put the pretend I or the pretend battery here. So with this opened and this shorted, we have 700 in parallel with 1K When we put that together, then we'll have that answer plus 300 ohms plus 800 ohms will give us our R Norton. I'm sure you guys can figure that out. But just in case you can't, let me do it. Okay, so we'll have, let me exit and go to the other part of the calculator. We have 700 in parallel with 1K. Shift reciprocal equals, shift reciprocal one more time, 4.12 ohms. No, 412 ohms. Then we have 412 ohms plus 300 plus 8. So 412 plus 800 plus 300 is 1.512 K ohms. So that's our R Norton, which goes here, 1.512 K ohms. Then the last thing we have to figure out is the voltage across the load resistor within the Norton equivalent circuit. Okay, hope this helps. Bye.